You're welcome to the mathematics class, and this will be our first mathematics class for the month of July 2020. In this class, we are going to look at mensuration, and the next series of videos we'll be looking at the concept of mensuration. So how do you measure shapes, different shapes, plane shapes, in terms of their lengths, their perimeters, their area, their volume. So, and we are in this very part, this is going to be the very first beginning. We're going to look at the length of an arc and also the perimeter of a sector and that of a segment. And just for clarity, we are going, before we know let's start with the length of an arc. So we start with this, the length of an arc. So before we know the real definition of length of an arc and how to calculate it, we should know what an arc of a circle is. So an arc, when you're talking about an arc, it means you're talking about a circle. And an arc of a circle is a fraction of the total distance around the circle, or around the circumference of the circle. We already know that the circumference of a circle is the total distance. Is the sum total of all the distances around the circle, and that is 2 pi r. That's the circumference of a circle. This is elementary mathematics. Area of a circle is pi r squared. Circumference of a circle, or you call it perimeter of a circle, is 2 pi r. And an arc is an area around, is a fraction of the total distance of the circle. So a fraction, just a fraction of this circle. So this is an arc, for example. This is another arc, for example, just a fraction of the total distance. So if I do something like this, and I complete that, let me complete that. In this case, this is a circle, although not a perfect circle. So the white area is an arc of a circle. The yellow area also is an arc of a circle. So a fraction of the total distance around this circle is called an arc of a circle. So an arc can be of any length. Like you can see that in this my diagram, this longer arc drawn with white color is a long arc, and the one drawn with yellow color is a shorter arc. So it becomes important for you to know the length of an arc. How long is an arc of a circle? And without mincing word, the length of an arc of a circle is usually denoted by L, and the formula for finding that is theta angle theta over 360 times 2 pi r. You already know that 2 pi r is the circumference of a circle. So you multiply that by the angle subtended by the center of a circle. And if you are saying theta over 360, it means that we have something like this. So the r is the radius of a circle. And the radius of a circle is the distance from the center of the circle to any part of the circle. So this is the radius of a circle. Let me use another color. So this is radius of this circle, which is the distance from any part of the circle to the center. Let's say this is the center of the circle. So the distance from here to here is radius. The distance from here to here again is radius. And there's an angle subtended at the center of the circle, and that is angle theta. So this part is the arc of this circle. This and this, from this length to this length, is the arc of the circle. And this is the radius, and this is the radius. So the length of this arc is this angle divided by 360 multiplied by 2 pi r, which means that you must be given your r, which is your radius. You must be given theta before you can know the length of an arc. Or the other way around, you might be given the length of the arc, and you'll be given the radius, and you'll be asked to find the angle subtended at the center. Or you'll be given the angle subtended at the center, you'll be given the length, then you'll be asked to find the radius. So it depends on how the question itself is projected. And let's take some examples. So, and this example states that an arc of a circle with a radius of 14 centimeters subtends an angle of 135 degrees at the center. Calculate the length of the arc. So it's usually good and advisable for you to draw the arc or the circle, the diagram somewhere. It's not important because you already have your parameters, but you might still draw. So the radius of this circle is 14 centimeters. So which means that from here to here is 14 centimeters. From the center of the circle to any part of the circle is 14 centimeters. And the angle subtended at the center is 135 degrees. So you are told to calculate the length of the arc. You already know that your length of the arc is angle subtended at the center over 360 times 2 pi r. And in this case, your angle subtended at the center is 135 divided by 360 times 2. The question says you should take pi to be 22 over 7 times 2, then multiply by your pi is 22 over 7 according to the question. Your radius is 14, so 2. So going by this, you get if you use a calculator, you get an answer of 33 centimeters. So the length of this arc is simply 33 centimeters. And let's take this as our example 2. It states that an arc which is 44 centimeters long, they've given us the length of the arc to be 44 centimeters, has a radius of 28 centimeters. Calculate the angle subtended at the center. We are told to calculate the angle subtended at the center. We don't know. And take pi to be 22 over 7. So we know that this is a relationship between the length, the radius, theta, and pi. So an arc which is 44 centimeters long, it means that they're talking about length of an arc here. And your length of an arc is theta over 360 times 2 pi r. You've been given the length to be 44. It means therefore that 44 is equal to, what is your theta? That's what you're looking for, over 360 multiplied by 2 times your pi is 22 over 7 and your radius is 28. So what you do in this case is you make theta the subject of the formula, and it means therefore this is over 1, this is over 1, this is over 1. It means therefore that you're going to have 44, if you cross multiply, times 360 times 7 is equal to theta times 2 times 22 times 28. So if you want to make theta the subject of the formula, or you want to find the value of theta, you say theta is equal to 44 times 360 times 7 divided by 2 times 22 times 28, because you are bringing all of this to this place. So you divide both sides by this, and that's how you get your theta. So in this case, you should get a value of 90 degrees. So it means therefore that the value of your theta is 90 degrees. So you might also be told to calculate the radius. Just know that whenever you are told about the length of an arc, or a question that speaks about the length of an arc, you're going to use the relation length of an arc is theta over 360 multiplied by 2 pi r. I'm going to take the last example on length of an arc from a typical WAEC question. So let's take the third example from WAEC past question. It states that what angle does an arc of length 5.5 centimeter subtend at the center of a circle of diameter 7 centimeter? So from this question, we know the our length of arc to be 5.5 centimeter. So like I said, you might just draw the diagram somewhere. So this is an arc of length 5.5 centimeter at the center of a circle of diameter 7 centimeter. The diameter of a circle is the distance between the 2 points of a circle. Between two sides of a circle is the entire internal length of the circle. So, and it means that if your diameter is 7 centimeter, your radius is half of your diameter. So your diameter is the length across, the total length across the center of the circle. So, and that is twice of your radius, because you know that your radius is distance from the center of your circle to any point on the circle. So this is radius, this is radius. And with this, we say that the diameter is 2 radius. And for you to know your radius, you divide your diameter by 2. So your radius will be diameter divided by 2. So what do we have from this question? We have the length of the arc to be 5.5 centimeters. And we also have the diameter to be 7 centimeters. And from this diameter, it implies that radius is 7 over 2, because your radius is always your diameter divided by 2, and that is 3.5 centimeters. So, and what are we looking for? We're looking for the angle theta. That's what we're looking for. From length of an arc is equal to theta over 360 times 2 pi r. So then, if you put these relations together, we'll get the angle we're looking. So let's put all the parameters we have in this formula. The length is 5.5 is equal to the angle we are looking for, 2 times 22 over 7, which is our pi, times our radius is 3.5. So, and from this, of course, 3.5 here 1, 3.5 here 2, 2 here 1, 2 here 2. So it means that what we have left is 5.5 is equal to theta multiplied by 22 divided by 360. And if you cross multiply, we say 22 theta is equal to 360 multiplied by 5.5. And theta is 360 multiplied by 5.5 divided by 22. So if you use your calculator, without using calculator, you can solve this, because 5.5 here is 1, by 5.5 here is 4. 4 here is 1, 4 here is 90. So you can say your theta is 90 degrees. But if you cannot do this, you can just use your calculator all through. Then you're going to get an angle of 90 degrees. So the angle subtended at the center is 90 degrees.